Alright, here's the update. We're going to show you the different voltages through this current limited Xmit LED modified custom circuit. Alrighty, here's the amount of voltage we got going into the voltage regulator. As you see, voltage regulator is right there. We have right there 15 volts going into the voltage regulator. Right there, 15 volts going into the voltage regulator. Here's what we have coming out of the voltage regulator. 12 volts, 11.92. That is a 12 volt voltage regulator. I think it's a 7812. So this is what I didn't add on the first version of this. I wasn't thinking correctly, because to do my math I had to have a specific voltage to do my math with. For example, we're dealing with a 12 volt load, a 12 volt source, voltage source. I'm needing 5 volts, so I need 7 volts to leave. So we use Ohm law, and first I have to know exactly what this relay's coil is going to pull, how much amperage this coil is going to pull. That's the most important part. This is what I learned from all this. So I learned that there's no way to pretty much know this unless you have the data sheet or test it with a meter. The relay's pulling 20 milliamps, so that's .02 mathematically. So you take your load, your amperage, .02, and you divide that by the amount of volts you are wanting to leave, which is 7 volts. And that comes out at 350 ohms. So that's what this is for, the variable resistor. Alrighty, and now I'm going to show you what it's coming out to when keyed. We have 15 volts going into the voltage regulator, 12 volts coming out of the voltage regulator. So what do we have coming out of the variable resistor? Let's see if I can get this. Let's see if I can get this on the camera. I only got 2 hands here, so. Pick up the mic here. Alrighty. Alrighty. Now we're going to key down the mic. Look at that. Voila, 5 volts. 4.85 volts. And actually, I didn't even think about this, putting all this into. If the LED isn't keyed up, it's sitting at like 5.8 volts. So with the LED keying down, it's sitting at a perfect voltage. Now the cool thing about this, I'll show you what's going directly to the coil. I actually have the coil voltage hooked up to, the actual output relay, because we're using the same voltage. Basically, I'm using the same voltage coming into it and coming out of the voltage regulator for the coil and to power the LED. So I just have them tied in together. So if you want to see exactly what's coming right after, literally right after the voltage, the variable resistor, is this. .92 before being keyed, and once the actual coil is pulling the 20 milliamp load, this happens. There's your 5 volts. See, the cool thing about this, which I learned, the variable resistor is putting 350 ohms of resistance on the voltage right now. It's putting 350 ohms of resistance on the voltage right now, but it doesn't become active. It doesn't drop the voltage until it's under a load. That's the part I didn't understand until I learned about all this. Alrighty. There's my 5 volts that I was wanting. I know this is something simple to a lot of people, but it's an accomplishment to me. And if you want to see exactly what's going to the actual LED itself with the current limited resistor that I have on here, is this. There we go. See, using a 470 ohm resistor, this LED is only getting about a volt. Let me get it on there good and sturdy. Sorry, I got so many connections around here. So the neat thing about it, this LED is getting about 1 volt, 1.15 volts. It's getting about 1 volt. So there you go, about 1.2 volts. So honestly, with this setup being as it is, I can almost use this LED without any current limiting resistance on the positive lead. But 5 volts still is pretty heavy for some LEDs. I think this is a 3 volt LED. So I actually could get away with putting about a 220 ohm resistor, or maybe even a 100 ohm resistor on it. But we're just going to leave it be because it's bright enough. Let's turn the lights out. Let's see what a LED does with just 1 volt going to it. That's 1 volt, my friend. 1 volt. I think that's bright enough if you ask me. And it's very quick response as well. I can just keyed up about 6 times. Hello. Hello. See, it works perfect. Alrighty, well, that includes this video. Appreciate you for checking it out. Like I said, it's something small, but it's a big accomplishment for me. Let me unhook this real quick, and I'll get a quick picture on the video of it. 1 second. Here she be. That ceramic disc right there is a 0.01 microfarad hooked up to the output of the voltage regulator in the ground. That is to keep the voltage regulator from self-oscillating, which is very important when you're dealing with RF especially. And there's the resistor that I also forgot, the diode I also forgot to put on there. Just protecting the relays coil from transient spikes, static electricity, shunts all that to ground. Also, on this variable resistor, I took some epoxy and epoxied that down so it cannot be moved, since it's so sensitive, because I'm using a 103, which is 10,000 picofarad. which is 10,000 ohms. I'm using a 103, which is a 10K, 10,000 ohms, and I was only needing to get 350 ohms out of it. So it took some real close precision to even get it to do 350 ohms, because that's real small. You know, for a 1K is what I should have used, but I just grabbed what I found. So, but I finally got it right there about 360, I think, or 340, somewhere a little under, and we glued her down. So there you go. Now I just got to figure out how to mount this puppy, and believe it or not, this little heat sink on here, I really didn't know if I needed one, but just to be safe, that actually is something off a door hinge. Fit perfect. Use whatever you can find. Well, there you go. Voltage regulated, current limited, transmit LED circuit. It will probably bring many, many years of a transmit LED. And at the end with this LED with a 470 ohm resistor, was giving the LED about 1.2 volts. So you put a 1K on, well, a 1K on one of these LEDs, you ain't gonna see nothing, since this is voltage regulated as well as it is. Hey, if I wanted to take a little bit extra precaution there, I could have got the I could have took this even deeper, put another variable resistor on the actual output of that variable resistor of the relay, and dialed that puppy on into about 2.53 volts, 2.5 volts or so. And then this would have been also an LED driver, to where you wouldn't even need no current limit on the LED itself. But you know, why do all that when you can just throw a resistor on it? Well, there you go. Gatekeeper Technologies in the making. Merry Christmas.